Hello guys, this is Saurabh Kumar this side. Welcome to my topic CMOS fabrication. Now let's go through the brief introduction towards my topic. Integrated circuits is a set of electronic circuit on one small flat chip of semiconductor material. Modern semiconductor chips have billions of components and complex to design. Now we will see the types of integrated circuits. Integrated circuits is of analog, digital, and mixed signal type. Now simultaneously we can see the types of digital designs used in VLSI. That is, full custom, every transistor designed and laid out by hand. Second one is ASCII, that is application specific integrated circuits. As the name suggests, it designs synthesize automatically from high level language description. And the last one is semi-custom, mixture of custom and synthesized modules. VLSI CMOS, that is complementary metal oxide semiconductor, is a fast, cheap, low power transistors, high packing density with very less noise margin. This technology is used in developing the microprocessor and microcontrollers, digital logic circuits, and major integrated circuits. Now let's see CMOS fabrication processes, which may include N-well process, P-well process, and twin tub process for CMOS fabrication. CMOS fabrication can be obtained by integrating both NMOS and PMOS transistors on the same chip substrate. Fabrication of CMOS is described using the P substrate, in which the NMOS transistor is fabricated on a P-type substrate and the PMOS transistor is fabricated in N-well. CMOS transistors are fabricated on silicon wafer. Lithography process similar to printing press. On each step, different materials are deposited or etched. Easiest to understand by viewing both top and cross section of wafer in a simplified manufacturing process. Now we will begin the steps of fabrication of CMOS by N-well process out of the methods discussed earlier. Now, step 1, substrate. Primarily start the process with P substrate. The oxidation process. The oxidation process is done by using high purity oxygen and hydrogen content, which are exposed in a oxidation furnace approximately at 1000 degrees Celsius. The third step, the light photoresist. The light sensitive polymer that softens whenever exposed to light is called photoresist layer. It is formed. The photoresist is exposed to UV rays through the N-well mask. The part of photoresist is removed by treating the wafer with basic or acidic solution. The SiO2 oxidation layer is removed through the open area made by the removal of photoresist using hydrofluoric acid. The seventh step, removal of photoresist. The entire photoresist layer is stripped off as shown. Step 8, formation of N-well. By using ion implantation or diffusion process, N-well is formed. Step 9 is removal of SiO2. Using hydrofluoric acid, the remaining SiO2 is removed. Next step is deposition of polysilicon. Chemical vapor deposition process is used to deposit a very thin layer of gate oxide. Next, removing the layer bearing a small area for gates. Except the two small regions required for forming the gates of NMOS and PMOS, the remaining layer is stripped off. Next, oxidation layer with two small regions for the formation of gate terminals of NMOS and PMOS. By using masking process, small gaps are made for the purpose of N diffusion. The N-type dopants are diffused or ion implanted and the 3N plus are formed for the formation of terminals of NMOS. Oxide stripping. The remaining oxide layer is stripped off. The next step is P-diffusion. Similar to the above N diffusion process, the P-diffusion regions are diffused to form the terminals of the PMOS. Thick field oxide. A thick field oxide is formed in all regions except the terminals of PMOS and NMOS. Aluminium is spurted on the whole wafer. The excess metal is removed from the wafer layer. Now, the terminals. The terminals of PMOS and NMOS are made from respective gaps. And the last step is shown. Now comes the P-well process. Fabrication of the CMOS P-well process is almost similar to the N-well, but the only difference is P-well process is that it contains of a main N substrate for the N devices. And here comes the last process, twin tub process. In this part, I have done some animations to better understanding for twin tub process. By using following steps, we can fabricate CMOS using twin tub process method. Lightly doped N plus or P plus substrate is taken and to protect the latch up, epitaxial layer is used. The high purity controlled thickness of the layer of silicon are grown with exact dopant contractions. The dopant and its concentration in silicon are used to determine the electrical properties. That's all from my side. Thank you for listening me. I am looking forward for your valuable comments.